let's begin by reviewing the graded exercise instructions which I sent to you yesterday. Here. Here. Okay, now I will share the screen. So, yeah, as we discussed last time, that the graded exercise 2 will be after we implement this Frogger game. And this exercise is worth 10 points. And then the previous exercise was worth 10 points. So maximum points from the course, therefore 20 points. The task is to implement a limited Frogger game with JavaScript and HTML canvas element. And here is a link we can play Frogger game. It's here. So the Frogger game looks like this. With keyboard, I'm controlling this frog here below. I have to get over the road. If I get hit by a car, then I lose a life. It restarts, and now again the car. So I have to get over the black road and not hit a car. And I need to get over the river and try to end up here in these goal slots. Go over these logs and turtles. Oops, and now I went to the water and it's game over. Continue. I can try to get again there with better luck this time. Let's wait a good moment now. Now I haven't managed to reach one of those goal slots. So the goal is to reach all those five goal slots. Now it's hitting water. So here on down, we have the black asphalt road. You can move there freely, but you have to beware the cars. Whereas here on the up, you have to use the turtles and then the logs as your safe passage. And if you pay attention to the score here, score 560, every time when I advance upwards, you can see that I get more scores. If I go below and then back up, I don't get any more score. Only when I advance more upwards. Let's wait for a good time. And then here I have a time running, which is also a limiting factor on how long I can wait. And then to the score, the remaining time will be added according to some logic, which I have not specified in the instruction. So this is the Frogger game. I have written here a list of these elements in the game. So we have these two saved zones in the beginning here on bottom of the screen, then in the middle of the screen, where there is no threat to the frog. Here is the starting location. On the black asphalt, the frog can move freely. We have cars, 5 rows or lanes of cars which are moving first left, then right, left, right, then left. And then here you have these logs and turtles which are also going left, right. I think this is also right, left, and then right. These logs are moving on a different pace. And the water is instant death, and these are the goal slots. So here different elements are described. And the timer, when the frog starts, there is a 40-second timer. 40-second timer, and if the timer runs out, then the player loses again a life. And there are three lives or frogs, however you want to call them. So the objective of the game is to gain as much score points as possible, and then when all 5 goal slots are filled, Then the slots are cleared, and then the speed, cars, logs, and turtles is increased. And then we should try again. Play as long as you can and get a maximum high score. So here is then a scoring matrix for our programming exercise. So here is the feature description on the left, and then on the right side there is the amount of points you can earn. So if you can draw some elements on the screen with Canvas basic drawing primitives, meaning rectangular, arc, and line with different movement, and then animate the movement of the objects. So here, as you can see, this is using this frog and these cars. They are drawn with these graphics. So for these viewpoints here, using these graphics, these drawn car images and these turtles and these logs is not necessary. Instead, you can get the 2 points if you are using simple, for example, rectangles of different color. If you have a yellow rectangle here as a standalone for a car, so a stand-in for a car, then that is totally fine. And the frog can be, for example, a green circle or whatever basic primitive you want to use. So that's what it means, that 2 points if you can draw a screen like this to the canvas using basic drawing primitives such as the rectangular, arc, line, and so on. So that's 2 points. And also get these moving these objects, so these cars and then these turtles and these logs. So that's the 2 points. Then if you can draw the game objects with these sprites, and also sprites animated. So a sprite, let's see how these games are created. Here. Here is the image. So this is a sprite sheet, a Frogger game. It's not exactly the same sprite sheet. So the images are not exactly the same as seen in this game, but it is from the same kind of game type. So a sprite sheet means that we have a single image, which then has these sub-images, as you can see. And here. So as you can see here, we have our frog, but the frog has four different, I don't know what this is used for, but it has four different images. So these are now called animation frames. So when the frog jumps, be it forwards, backwards, left or right, an animation using these four frames are being played from this sprite sheet. So how it works is that there will be a call in the code to draw an image, then draw the image on a certain location on the screen, and then from this image, first from this coordinate, then from this coordinate, then from this coordinate, and then from this coordinate. So this is a sprite sheet. It is a single image which has sub-images for each object in the game. And here is, for example, this log. So this would then be drawn to the screen on its own. There is no animation in that. Here are the turtles. So for basic movement, so the turtle, when it moves, it is swimming. So this animation of these 5 frames are being played over and over again. So it looks like it's flowing. And then there is also a different kinds of sheets for, I guess this is a submerged turtle. So when turtle is swimming partially underwater. So this is what it means that there is a sprite sheet. and so this section means that instead of drawing the game with boxes or circles of different colors, a sprite sheet is used to draw with actual graphical images, these cards and the frog. And then to get the full 1 point, also there would be the animation, so that, for example, when the frog jumps, an animation of, for example, those 4 frames being played. Without the animation, this would be then half a point. Then if you have a keyboard control, so that from the keyboard you can move the frog, that's then 1 point. Then if you have collision detection with frogs and cars, so that if the frog is hit by a car, then the player loses a life. So that's 1 point. Then when the frog gets killed, then there is a respawn, and respawn means that so respawn means that the game starts again. So now here I have this frog. Now if it gets hit by a car, bang. Now this was a respawn event. So the frog is created again, 1 life is subtracted. So that is what it means by respawn. So if that thing works, then that's 1 point. Then if there is a death to the frog player by touching water, that's 1 point. So basically when it moves like this, and then if it jumps to the water, and that's then death to the frog. So that's 1 point. And then if you manage to do it so that when the frog moves on top of the turtle and logs, it is carried away. So there is not a death. So this would be possible. This is worth 1 point. So that you can move on top of these turtles and logs and then get carried away. So that's 1 point. Then if you can make it so that there is detection that now the frog has reached this goal slot, and then a new frog is spawned at the location without losing a life. So meaning this situation that when I move here, when my frog gets here, now when I jump there, now there is a detected that now I have reached the goal slot, and a new frog is created here, but I don't lose a life in the game. So this logic, if you detect frog player has now reached this goal slot, that is worth 1 point. This. And then if you can make it so that you can count score, count the remaining lives, and also ending the game. So meaning that if the player loses all the lives, so now this is the last one, like so that you can detect that now all lives have been lost, and the game must be restarted and then announce it in some way to the user, to the player. That's worth one. Okay, do you have any question about this implementation scoring? So altogether these make up 10 points. So basically, if you're able to create a fully working game, you get the 10 points. If you do only parts of it, then you get less points. And then how to deliver the game and what is the schedule. So it's the same as what we did for the last exercise. You must have your code in the public repository in GitHub. Now, because this is using a canvas element, so there must be an HTML page. Page must be named index.html. Then you should again host your game at pages.github.com so that it can be tested. Now, I think you can only host a single page, a single website here. So this was also instruction for the last exercise as well. So now what you must create is that you must basically create a portal web page of sorts that you have link to two of those different implementations for exercise 1 and then for exercise 2. So they must be here also, so that it's easy to access both of those. And then you must deliver the links to these two above. And again, we are going to be using a graded exercise 2 workshop. And as in previous exercise, you must do peer reviews of 2 other ones. So it means that you need to check the work of 2 other students, see their game implementation, and then based on this implementation scoring matrix, you then must decide what would be the score, what you would give for that student implementation. So the deadline for this one is Thursday, 4th of March, midnight. And peer review starts automatically after that. And the peer review should be completed latest by Sunday, March 7th by midnight. So the deadline of the implementation submission is Thursday, so that will give you a Friday time to do the peer review if you want to avoid doing it in the weekend. Right, so any questions about this? This has now been posted to Moodle, and I have sent this link to this document to you also in email.
Would it be possible just to make another like GitHub pages, or do we have to do a portal page for that?
Well, I don't know. I have not really used these GitHub pages myself, so if I recall correctly, you can have one site hosted per GitHub user account.
Oh, okay.
That would mean that you would need to have a single website which shows both of your exercise 1 and exercise 2 at the same time. It's not really, I don't think it's a good idea to create a second GitHub user account just to avoid that one. Portal page is basically a single HTML page with 2 links.
Yeah.
I think it takes like maybe 10 seconds to do it. It's not that big of an obstacle, I think. Okay, any other questions? Okay, and I suggest that you get started right away for this exercise and not try to leave it to the last minute. And also, as I said previously, please don't try to fool yourself and me by trying to submit a solution taken from internet. So that is an extremely stupid thing to do. The outcome will be so that I will have to raise the issue to the school disciplinary board, and that is something what I really hate, because it is total waste of my time. And also it will result in a whole failed course for you. Then you will need to do both exercises again from a new different topics. So that means again extra for me, because then I will have to come up with the instructions for those extra works and then again review your works, even though I've just done them. So if you try to submit a work taken from internet, you will only waste a lot of my time, and that is not what I like for. And you will also waste your time quite significantly. So please don't try to take a solution from internet and present it as your own. Instead, do your best to achieve this one. If you don't know how to do something, then seek help. Then I can try to guide you on how you could implement it. And that way you can learn the best. As far as I recall, you are in school to learn something, learn a profession. If you try to cheat your way through the school, then only person who you have cheated is yourself, because there is no way how you could get paid to do a profession, to do software engineering, if you don't have any skills but cheating. it will not take you very far. Okay, let's get then to the canvas thing to learn more on the details. How could we do this? So today we'll continue from where we left on last time. So then we had the bouncing ball. So we'll work a little bit more with that. And then today we'll also introduce keyboard control, the same exercise, so that we could control an object in the drawn to the canvas. And then we'll also see on how to draw images and how to draw parts of images to the canvas. So then you could draw, for example, this log to the screen from this sprite sheet. Okay, so yeah, okay, so there is a question in the chat. So I only need to submit 2 links which are Frogger game pages. So here it says that you must have your work in public repository in GitHub, and then you must have your game hosted for exercise 2 and exercise 1 hosted here at pages.github.com. So you must deliver your link to the source code, wherever that is, and then you must have a link so that it is easy to see your implementation of exercise 1 and exercise 2. So yes, 2 links must be delivered. And you deliver them to the graded exercise 2 workshop in Moodle. So now we will continue from our work, which is available in this repository. If you don't have the same work already on your computer, so here is the link. You could clone this repository, and we will be starting or continuing our work from here in free canvas. What I will do is that I will take this file and copy it, and then we'll have a second file where I can do some more work, and then this file example from our previous lesson will stay in that. So if you want to have the same starting point and follow what I'm doing or play around, then you clone this repository, and the link is now in the chat. I will now open my local clone of the repository here with Visual Studio Code. And just to remind you that what we did. What we did before. Let me show you on the screen. So it was this kind of thing where we had these balls bouncing up and down. So we had a basic collision detection on top and on bottom of the screen, and then we created these balls by using the class. So each ball have their own coordinates, their own speed, and each ball are doing their own collision detection. So we are using objects to deal with these the processing logic of each of these ball in the screen that you're seeing. So each ball is now an object of its own. And this is the code what we had. So we had about 70 lines of code. We have only a single HTML element. Here is the canvas, which is using the draw of the screen. First thing what we do is that we select that element, and then from the element, which is known as canvas, we get something known as context. And this context is the interface or the object with methods which allow us to draw to the canvas. And this is a one-time operation only. Then what is happening here is that we are setting the size of the canvas element to be the size of the whole window. So that's the reason why if I have here a small window and a reload, you can see that the objects are bouncing from here. If I make this bigger one, you can see that the canvas remains as the original size. But then when I reload, now the canvas is sized to be the whole size of this window. We are not doing resize of the canvas if the window resizes. That would be a separate event. You can do it if you want. Then here we had some basic drawing codes, which is not really in effect. So this was an example on how to draw a line from these coordinates to these coordinates. But this is only visible during the first frame. So we are basically drawing here the screen about 60 times a second. So this line, what is here, it gets erased very fast, so fast that you don't even see it. So this code basically doesn't have any effect. And yeah, these are leftovers from our example before we moved to this class syntax. So before we did it with the class, we had a single ball, and then we made a second ball, and we were tracking the all coordinates here with these variables. Then, if you remember, we noticed that it doesn't make any sense. We end up doing lots and lots of duplicate code. So then we switched our code to use this class and objects created from this class. And now these are not really used. So actually what I would do is that I will delete these, then commit this to the repository later on so that it doesn't confuse you. So each of the balls in the screen, what you saw, are now represented by this class. So the class is created by using this constructor function, which is executed when we call new balls. This new keyword, then the name of the class will trigger execution of this constructor function. And these parameters, what are given here, are parameters of the constructor function. So start x, start y, and speed, all these three parameters are then stored into the object which is created from this class that you can know because there is this keyword, this x, this y, this speed. X, y, and speed will be properties of the objects what we create from this class with keyword new. Then this class has two methods, so update and draw. The job of these two methods, as the name says, that this update will deal with all the logic, whatever that might be, for this logic for this for objects created from this class, and then this draw will take care of drawing this class to the screen. So now, if you would like, for example, to modify our code so that we are not using, let's say, canvas, but we would be creating DOM elements, for example, divs. Then what we would need to do is that we would need to modify this draw method only, because modify this draw method only, because this is the one which is actually doing the drawing of the object to the screen. Okay, so this is just the class structure. Having this one doesn't create actually any of the objects to the screen. To have the objects actually exist from this class, you must create them, and that's what's being done here. So we have an array of empty array here at line 39 with the name ball storage, and then we have a loop, and we create 8 new balls, which are then stored in the array ball storage. And we have those those eight game objects existing. So then here we have a function. This is basically our whole application now. So we have this update screen, which we call from window request animation frame. This is now a method offered by the browser, which allows us to, as the name says, to request that this function is executed next time when the browser updates the screen. And this we indicate that we would like to have done as soon as possible. Then what is being done here in the update screen function is that we are clearing the canvas, and then we are updating all our ball objects, and then we are drawing all of the ball objects. Then we request a new redraw of the screen. So please execute this one again. So if I take this one away, comment, you can see the difference that if I don't update, clear the screen in between, I can draw to the screen, but everything what I just drew will be then also there later on. So get this kind of effect. So we want to clear the whole screen so that we can see the individual objects there. Okay, any questions now about this before we move on? So now I will make a copy of this one. Here, number 2, and then let's say all collisions. So that will be the target of this file. So now what we would like to get done so that our balls don't just move in this kind of vertical manner, but they would also have some horizontal movement as well, so that they could move and then also bounce from these left and right sides. So now to get that one, we basically need that we represent the speed component in both axes. So now we have a two-dimensional screen, and our balls are currently moving in one dimension only, so on this vertical axis. And that is now represented by this speed. Now if you would like to have some movement also on the horizontal axis, on x-axis, we need to represent the speed in that axis as well. So what will happen is that our speed will become in fact speed y, speed y, and then we will have also speed x. So now we have coordinates for the ball objects. They are located in these x and y coordinates, and then they should have this speed in the x-axis and this speed in the y-axis. So we'll put here also, we are storing the speed in the x-axis. And now what I will do next is that I will clear this, modify this. We only have a single ball on the screen so that it's easier to track. No, it doesn't work. We need to all the parameters. We have 3 parameters. We added a new parameter, fourth one, so we need to that one. So let's put here that we put fixed coordinates for this one. So 100 and 100 x and y. Then let's say that the speed in the x direction should be 5 and 10 in the y direction. But then we must also use it. Now we have just saved it here to the objects. We must use it, and we'll do it the same way what we did here, so that speed x affects now the x coordinate. So this x equals this x dot this speed x, like this. Now we have two independent axes of motion affecting two independent coordinate axes. Now if we see our situation, our ball is now moving sideways as well. So all what we did is that we added the x-axis amount of x-axis movement there, and now it moves not only downwards and upwards, but also sideways. Now you can see the problem here is that the ball is vanishing when it gets outside the screen. It still exists in the computer memory, but the x-coordinate and y-coordinates are getting so big, or sorry, the x-coordinate is getting so big that it no longer fits the screen. Make this smaller, so it's much situation. Zoom. So now we would need to add collision detection also to the right and left side of the browser window. That one will work exactly the same thing as for the top and bottom parts. So we'll add here a new if statement. If this x gets bigger or equal than canvas width, then what we will do is that the speed x will reverse it. We will reverse the speed x when we hit the x coordinate becomes bigger or equal to the canvas width. So basically when the center of the ball hits the right edge of the browser window. So you can see here, now it comes back. But now it vanishes from here. So now we would need to add collision detection also here to the left side. That again works exactly the same thing with the same logic what we did here and what we have done already here and here. So I like to write it like that, even though it's not necessary from the syntax point of view. I think it just makes it more clear. So what we will do is that we will reverse the axis if the x-coordinate of the ball is bigger or equal to the canvas width, or if the x-coordinate gets smaller or equal than 0. So the 0 is now the left edge. Since the coordinate axis, the 0, 0 location is here on top left, and then x-coordinate grows here, and here in this direction we have a negative x-coordinate, and y-coordinate it grows here, positive, and then here this is negative y. So that's the reason why this logic works like this. Okay, let's see. I have saved it. Let's try. Now it moves there, bounces, bounces. Okay, quite nice. Now we can see again, if we increase the amount of these balls by, let's say, 10 balls, then we must modify our coordinates so that, well, maybe we add to the I times 2 x coordinate. Much times 2 times 20. So now we have 10 balls all moving in unison. It doesn't look very nice. Let's change also the y coordinates. But actually, let's make it so that it's totally random. But this will keep looking quite weird. So make it so that this is random. So math random, and this math random will give me a random number between 0 and 1. So now what I will do is that I will multiply it with the canvas width. Now it will be anywhere on the canvas screen. Now we'll do it here also, math random canvas height. Now we will have totally random x and totally random y coordinate. Now the balls are bouncing here. They have equal amount of speed, both in the x and y axis, so they look like they are moving in a quite coordinated manner. If we put random speed to them, math random, then we multiply the result, because math random is indeed random between 0 and 1. So if we multiply it with 10, then it's between 0 and 10. Then do the same thing here with these 10 again. Now this becomes quite long code line. Let's break it up a little bit for easier reading. Like so. So this is the x code, this is the y coordinate, this is the x speed, this is the y speed. Okay, so now they have totally random speed values and also in both of the axes. But as you can see, all of them, when they start, they are moving downwards and right side. And that is because all our x and y speed values, even though they are random, they are between 0 and 1. So that means that they are always positive. So because our coordinate axial system was indeed so that it's downwards and right sides is the plus. That's positive and positive. So now when we give positive random values to x and y, it means that we are giving them movement values on this arc, basically. So movement is something like this direction in the beginning. We get totally random movement values for the objects. For the balls, we would need to here a random either plus or minus. What we could do, maybe it will become a little bit complex this, but well, let's do it anyway. I'm going to do here that we multiply this with here and then math random. So this math random will be between 0 and 1. Now we use a single line if here, so it's called ternary operator. Ternary operator means it's a conditional single line if. And you use this question mark and then there is a colon. So when we write like this, is member question mark some value colon some value. So what happens is that this on the left side on the column is the result of this operation when this is member is true, and when is member is false, this is the result. So this ternary thing is like a single line if statement. So now I'm going to use that one here. So I'm going to check that if this one is bigger than 0.5, then I'm going to return 1. And if it's smaller than 0.5 or something else, then I'm going to return -1. So in essence, this will return randomly either 1 or -1. Therefore, when it returns -1, this becomes negative, and therefore we have a negative value. Randomly created negative value for the x speed, and then let's put here the same thing for the y speed. So this is a single line if. Of course, you would have written here also something like if math random bigger than 0.5. We have done like this, that let random x direction equal 1, for example. Then if this would have been happening, so then x direction is -1. So it would have been like this as well, so that we could have here random x direction. This is now the same thing what we have here, but keep it like this. Now we should have totally random ball movement. What we have there? Yeah, it's here. Yeah, missing brackets. This bracket here is matching for this one. The problem. So now, as you can see, some of the balls, they are starting their movement also upwards and leftwise, and not just always downwards and right. Now we have some more randomness there as well. Now let's keep on adding some more random things here to separate these a little bit. For example, the sizes of these balls, we could have here that this radius is that not random. And then from, let's say again, from 0 to 10, so we could use this radius then, well, let's make it 30, or even bigger, 50. So previously we have had here the radius to be fixed 30. So we can also randomize that one, this radius. So now when we create a new ball, the radius will be randomized. We'll have the big ones and small ones. All of them up. Then what we could also do is that we could change their color. So this setting the color of what you are drawing is a useful thing. Get the first integrated exercise, this draw elements on the screen. So the idea is that you would draw with, let's say, arcs or rectangles, these basic objects. So then they would also need to be different colors. So if I set the color here, this color, we put this as an object. So red, path random from 0 to 255, green, same thing, blue, and same thing. And here we have set the fill style for these circles before. Now what I'm going to do is that I'm going to be using these red, green, and blue values to set the fill style, because I can also, like in CSS, I can use these fixed keywords like red, and I can have the hexadecimal values. So like so, you can see how it looks like with that. That's this yellow thing. And then we can also give a color using this RGB thing, and then, for example, 1, 2, 5, 0, and then the 200. So this is also valid syntax for these color values. So now what I will do is that I will take these properties and put them here. So to do that, I will change this from this kind of normal string to this backtick string, this string literal template. But it's easier to put the values there. So this one will be this red, this green, and then it gets the rest of it. Now I'm creating the RGB string with the value of this one, and this one. And now I have actually an error because the color and not just directly red. So we have this dot color this dot for, and then this dot for, like this. Now all these balls, they have now independent radius, randomly generated, and now they have also random colors. So now if we increase the amount of our balls on the screen to 1,000, for example. So I think this is a pretty good illustration of the power of what we can do with dealing with objects. So that it's very easy to deal with a large number of data items when they are organized into objects. So from this, you can probably guess that if you think about that, how should you organize your Frogger game, would mean that instead of having this ball storage here, you have a centralized storage where you have all your game objects. And then all your game objects you would call update and draw, no matter if they are logs, no matter if they are the turtles or cars or your frog or whatever. All of them should be updated and drawn at the same go, and here you can see the result. So it's just the same if I have 1 or if I have 1,000 of these. So logic of the code is still the same. Or 10,000. Now it gets a little bit slower. 5,000 is still manageable, only slightly. 150 is an easy thing to do. Okay, so now if you think about the Frogger game based on this one, we have the different game objects there. We have these cars, we have these logs and turtles. How are these cars moving? What kind of values would you set to the cars? Think about from this code. So if we would have here something like that, we could create one car and we would have new car, and then we would create it. What would we give values here? So think about this. This here, and when we create, we will initialize the object to some x coordinate, some y coordinate, and then give some x speed, and then give some y speed. So what do you think should be the value for the y speed? Do these have any movement on the y axis? Yeah, on the chat there is that, yeah, it's 0. When these cars are moving, there should be only 0 movement on the y axis. And then when you're creating these in the game, it works so that there is constant speed on every lane. So the first lane here, this first row, when cars are moving left, they have a constant speed. Then the second lane, where these, I don't know what, these tractors or something, they're moving to the right, they have a constant speed on that lane. And then this on third lane, these also have constant speed. So what you would do is that when you create these objects here for the first lane, you would give constant speed for all objects on the first lane. So the same x speed and y speed be 0. So now if we think about that a little bit further. Oh wait, okay, not before we go there. let's have a short break and then see the second thing what I was talking about, this keyboard input. And then after that, we can see a little bit how to do these bars, for example. So let's have a break of 15 minutes and then continue. So we continue at 11:15. And in the meantime, I will put the code what I have here to GitHub. So if you want to get a fresh update to the same code to your computer, you can make a thing. So okay, now it should be there in the GitHub. Both of these files and these changes. So if you want to get the fresh update, you can do it. All right, now let's have a break of 15 minutes. Okay, let's continue. So, keyboard input. Keyboard input, what we'll be doing here is it's in no way like Canvas specific. So it's just general input thing, which we will add there as an event listener. And first thing what we must decide is that which element shall we add it. Now, because we have a game, I think we'll add it to the whole window so that anywhere where we click when the browser window is active, or any no matter what element we have active, when the browser window is visible, the keyboard events will be working. So I'll put it here. So window add event listener, and then this takes two parameters. First parameter string, which describes the event. And the second parameter is then a callback function, which to execute when the event happens. So you have an event called key down. Then we have here a function which we want to execute when this happens. Let's try this. For example, like this. So an event listener for the window for the key down event. This function should be executed when there is a key down event. See, does it work? No? Immediately. Var is not defined. Oh yeah. Here I have some examples. Okay. So now, that's there. Now when I click somewhere here, it says hello keyboard. Next thing is to the next step is to see the information that which key was clicked, because obviously we need information on that. And that is given to us by the JavaScript engine as a parameter to this callback function. So we can put here event like this. Let's see what is this event object. There's this kind of keyboard event, and here you can see key is H. I was clicking H, and here is some kind of which. This is code, key code 72. If I click letter A, now I got here a second one, key code 65. Okay. If I click letter B, I get a new key button. So we get information on the key which was clicked. If I click on arrow up on my keyboard, now there is arrow up, key code 38, arrow left, down, and right. I'm gonna take these key codes and then print based on those. So let's do here a switch and then event. And then there is a key code. Let's make a switch based on that one. And then if case that is for the left. Let's begin from the up. The key code 38 is for the up. Right? Then case, what is then the next key here? Left. There's the key code 37. Right? Then arrow down is key code 40. Down. And then arrow right, key code 39. Right. And then I will reorganize these so that the numbers are progressing nicely from smallest to the biggest one. Let's see, we get now left, up, right, and down when we click on the keyboard arrows. Up, left, down, right. So now we have capability of reacting to the keyboard. Next step, what we would need to do is to create something that we can control here on the screen. So to do that, I will create a new object here. I will draw a rectangle, say a green rectangle. And the objective is so that it will move. It will move when I click on a keyboard arrow, either left, up, right, or down. So first thing what I will do is that I will decrease the amount of these moving balls to only a couple ones so that they don't irritate so much. And then I will create this rectangle. So now let's put the amount of balls to smaller to, let's say, 5. And then I'll start to create now this player object. So class, the player is now an object what I can control with key. Class player, and then constructor. And then now I need to think that what kind of properties I should have for my player. I would need to have, again, where my player is created, X and Y. And then maybe I will put there that there should be movement speed, not constant speed, but speed where it moves. But before that, okay, let's use the movement speed X and then movement speed Y. Okay, let's do it like this. So then I will save these to the object. Like so. Okay, now X, movement speed X, movement speed Y. Then my player will have these same methods. Update and draw. And let's just do the draw first. And what I want to have is that I want to draw a rectangle. Here is a quite neat collection of canvas information on this HTML5 canvastutorials.com. So now if I want to create a rectangle, I can quickly check out here what I need to do for that. That is the rect. Here I have some information, example. Coordinates, width, and height. And I go begin path, and then I'll just copy this path. So my player will be a rectangle, like so. Yeah, I can put it to the chat. There is the link to this page, so you can also copy this one if you want. And here is nice reference for this. Basic. Okay. Yeah, it happened that the code what I was using the same name for this context, this global context. I have to rename this one. Unfortunately. Okay, begin path, then rect. These are the coordinates then. Fill style, fill, line width, stroke type, stroke. So this one will fill a rectangle with this color. Then this stroke will draw the borders rectangle with these properties. So you can decide, do you need to fill the rectangle or just rectangle borders, depending on the situation. Now, these will be this X and this Y, and here is the width. No, let's use 50 and 50. And my fill style for the player will be, let's say, green. Green, and then like this. Now we should be able to see a green rectangle in the given coordinates. We don't have yet any capability of controlling it, but that will be later on. So now we'll need to create an instance of this player object. Player. And X, Y. Let's put them to 300X and 300Y. Then the speeds will be 0 at this time. Let's just see if we can see it on the screen. see it on the screen, we would need to call the draw method. Therefore, we must go here. We have this update screen function, which is operating our whole application. Again, it needs to be a game. So player, and then draw. I'll put the update there as well, since we didn't have any. Even though we don't have anything yet, but maybe soon we will have something in updates. Okay, we have created this class of a player with update and draw methods. Update method is empty. Draw method will draw a green rectangle with the coordinates given player when it's created. And here we have created this player object, these coordinates, and then in our update screen function, if it is better name would be update game loop. Maybe game loop would be better name for this. That's a bit like this for now. So here we have then calls for the update and draw. Okay, let's see, can we see now? We see it on the screen. Yeah, then we have our green rectangle. And we have also capability of detecting keyboard inputs. But okay, now it seems like it's moving because it's moving these scroll bars. Now there are no scroll bars, it's not moving. But the next thing is to connect our keyboard so that this would move. Okay. Let's see. Here we have said that our size of the rectangle is this 50 pixels. And then we have this movement speed, X and Y. So I'm thinking we'll do it this so that when I click on the arrow, it will move like upwards, left, down, or right by the amount of its self size with an instant jump. So basically we'll move it by the same 50-50. So I'm going to put here movement speed X 50, Y 50. And then here in the update, we now need some way of detecting the keyboard thing. Here we have this event listener. So somehow we need to pass information from here to here. The idea is that when key up arrow is pressed, so then decrease Y coordinate by the amount of movement speed Y value. And then for the left arrow, right arrow, down arrow, the same thing. And then just manipulate the correct coordinate. So what we could do is that we create some kind of global objects which could be called, or actually now we have this player here is a global object. So what could happen is that we could have simply let's try this one. If we have here move up, let's try it like this. But actually this one would be here in the move up. So this Y equals this y minus this movement speed y. So then this move up, we could do is that we could call it here. Let's try. We have the player object here as a global. Player move up. Let's see if it works. So here we have player move up, and then here. Let's see. Does it work? Yeah, it actually works. Now I'm going to do the same thing. Move down this y equals this y. Oh, and move x would be done with the same logic. I'm sorry, move left. Move left. So this x is this equals this x minus the movement speed. Move right. And then this x plus the speed. Okay, maybe this could work like this. Then we can just call move up, move down, move left, move right, and we have a keyboard input. This could work quite nicely. So player move left, player move right, and here player move down. Let's give it an action. And now what I'm actually going to do is that also that I'm going to take away the full window size, this box, and I'm going to decide that my game size would be, let's see, what is the size of the Frogger game actually here? I'm going to use the same size for my, okay, we have a 672. Okay, let's use the same thing. Yeah. 672 and 744. It's always the same size. Doing like a resizable game, it's not very convenient. So now we can move our box here. We'll go over the edge of the canvas, but we can get it back here like this. So now in the Frogger game, at least in this one, if we see how many jumps how many moves does the frog have? So on the left side it has, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. Okay, so 14 times frog to move. So if the width is 672, so if you put it 672 divided by 14, we get that it would move 48 pixels at a time. So then here when we are creating it, let's say 48, and then let's set the starting coordinate also to be so that it's on the 6th, so 6 times 48, 288. 288. So now it's nice and even. This should be nice and even. Now it's nicely on the edge of the. There is one bit. No matter. In any case, we can now move this nicely. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then we have now our green box is moving with the same amount as in the Frogger game. So next step would be to do the same thing for the vertical axis as well. You can do it. Okay. So we have some questions now so far about what we have done. I will make a comment of this so you can get it immediately to your own computer if you want. So, right. So now we have about 40 minutes of time remaining. I'm thinking that next, what you could do as a practice is to take this code from the repository or use your own if you have managed to follow, which would have been quite difficult. We have been going quite fast. But in any case, make it so that within these 40 minutes, you would try to create a brown rectangle which moves from, or a gray rectangle in any case, so that an object which would move from right to left and from left to right, like this. So you would have, for example, these kind of rectangles which would be moving. So these could be placeholders, representatives of the cars, for example. So that could be a task for you in the next 20 minutes. So that I'll split you up in the breakout room, so you can discuss if you have any other questions or something like this. So that's the task. Take this code from the repository. I've just updated this, so you can take this one or use your own, and then try to create this kind of moving rectangles from left to right and from right to left. Try to make at least that there are two different sizes, so a bigger one and then a smaller one. That's the task. I will now create the breakout rooms. This my pen here. And also I will stop the recording now. Stop the recording now. The breakout rooms are now open and you have been invited to join. So please join a breakout room and then start to think about how would you implement a moving rectangle from left to right and right to left.